So Malfurion Storm Rage weighs 100 kilograms and is therefore experiencing a normal force of 0,980, 0 newtons. The coefficient of static friction between Malfurion and the ground is 1. The direction of the force of static friction is in the negative x direction. The first question is, what would be the minimum amount of force in the x-axis that it takes to overcome Malfurion's static friction and move Malfurion? The second question is multiple parts, and so we have Mirrodin Bronzebeard hits Malfurion, who is at rest, with his Haymaker ability and is in contact with him for 0.5 seconds. Mirrodin's Haymaker ability can generate 15,000 newtons of force. Malfurion experiences a kinetic coefficient of friction of 0.9, and all the forces are in the x-axis. And so the questions we want to ask, or answer rather, are: does Malfurion move? What will be Malfurion's change of momentum immediately after he gets hit with the Haymaker ability? So, question 1 is the minimum of force to move Malfurion. So we have his mass, and I take the magnitude of the normal force, because we need the magnitude in order to solve for the friction the static friction. Coefficient of static friction equals 1. So it's the coefficient of static friction times the magnitude of the normal force, which is going to equal 980 newtons, which is the first question. That's the amount of force it's going to take to move Malfurion. The second question is, does Malfurion move? And the question we ask really is the force applied greater than the force of static friction? And yes, Mirrodin can apply 15,000 newtons of force with the Haymaker ability, and the amount of force it takes to Malfurion is 980 newtons. This question is, what is Malfurion's change in momentum? So we want to know what our F-net is, and so our F-net is going to equal the force applied subtracted by the force of static friction. And that is demonstrated in our free body diagram. So we have Mirrodin here, Malfurion Storm Rage here. The gravitational force and normal force are canceling out, so there's no net force in the y-axis. There's only force in the x-axis, because Malfurion's, the force that Mirrodin applies on Malfurion is in the positive x direction, and the force of static friction experienced by Malfurion is in the negative x direction. So let's see. Let's zoom out a little bit. Yeah, it's F-net, and it's a force applied subtracted by the force of static friction, because this is in the positive direction, this is the negative x direction. So it's 15,000 newtons subtracted by 980 newtons, which equals 14,020 newtons. Then we have our delta P equation. We plug in F-net, plug in our our delta T, which is 0.5, and we get 7,010 kilograms meters per second. And that is it.